5, day 1, dealing with complex numbers and roots. Please don't write this example down. I just want you to practice it with your calculator. Enter into your calculator the square root of negative 52 and see what you get. Do you get something that looks like this? It says non-real answer, or an imaginary number, or answer doesn't exist. Here's the reason why. I do want you to write down this definition. An imaginary number. When you take the square root of a negative number, so that's your r, what you can do is you can replace that negative with the letter I. So that I will go out in front, and then the number will stay underneath the radical. Why you can do that is you can rewrite this as a square root of negative 1 and then times r. We'd like to just jump to that. Here's two circles. You don't need to write the circles down. The blue circle just talks about the real numbers like 1/2 or 0 or negative 9.6 square root of 5. Imaginary numbers are the ones in the green circle. I, 4i, negative 5i, or square root of negative 3. What we'd do is we would change this as a final answer as I goes out in front of the radical and then 3. Again, please write that definition down of an imaginary number. The square root of negative r equals I square root of 4, r. This example I don't want you to write down. Here's what happens when you have an imaginary root. The parabola, what you see here, f of x equals x squared plus 1, there are no x-intercepts. This parabola is above the x-axis. So if you get answers in this section that has a square root of a negative number, then you have an imaginary root. And you would not have any x-intercepts. They would be above the x-axis. All right, so we're going to go ahead and do some simplifying. These examples I would recommend that you write down. First example, we're going to simplify the square root of negative 6. So we have a negative underneath that radical. So to simplify it, we put an I out in front. Now it's a positive 6. And then if we see if we can break down 6 into prime factorization. Well, 2 times 3 wouldn't work, or 6 times 1 wouldn't work. We'll go on to the second example, the square root of negative 8. Again, we have a negative number underneath the radical, so we replace that with an I, and then 8. And we see if we can break down 8 as 4 times 2. Now remember, the square root of 4 is 2. So we can pop out a 2, and then we're left with a 2 underneath. Example C. We have 3, and then we're going to replace this negative again with an I, and then the square root of 49. Now remember, the square root of 49 is 7. So we can pop out a 7. Now you multiply like parts. 3 times 7 is 21, and then I. Remember, I represents the square root of negative 1. Now these two examples, we want to solve these quadratic equations. You're going to hear the two different words for it. Some textbooks ask you to find the roots of the quadratic or the zeros of the quadratic. So we're trying to find out what can x equal in this equation. So we're going to solve by undoing. I would recommend that you write these examples down. So example A, x squared equals negative 81. We want to solve for x, so we're going to undo the x squared. So remember, we square root both sides. We cannot forget the plus or minus in front of that right side. So the square root and squared cancel out, and we're left with x equals plus or minus. And now what happens is we have a negative radical. Let's replace that with an I out in front. And then we try to break down 81. Well, 81 is a perfect with 9. 9 times 9 is 81. So 9 pops out. So our final answer is plus or minus 9i. Let's go on to example B. 5x squared plus 90 equals 0. So we'll solve by undoing. So we're first going to undo the plus 90. So we're going to subtract 90. Then what would we undo next? The 5. So divide both sides by 5. So you get x squared equals, and then negative 90 divided by 5 is negative 18. Now we're going to undo the squared. So we're going to square root both sides. Don't forget the plus or minus. That's that common mistake we talked about when we were solved by undoing. The squared and the square root cancel out. Plus or minus. Now we have a negative underneath the radical. Let's replace that with an I out in front. And then we have to break down 18 into prime factorization. So we can break down 18 into 9 and 2. And then what happens is that the square root of 9 is 3. So the 3 is going to pop out, and then the 2 stays underneath as a leftover. All right, solve this quadratic equation by finding the roots, or the zeros. So now we can't solve by undoing anymore. We're going to try and either factor it or use the quadratic formula. Now if we try to use the chart method over here, and we say what are the factors of 35 that add to the middle term 10, well, you'd say 5 times 7, that adds to 12. So we can't factor this, so we can't use the chart method. So what we're going to use instead is the quadratic formula. So we'd identify the A, B, and C. And plug it in. So x equals, and hopefully now we kind of have this quadratic formula memorized, negative b plus or minus b squared minus 4ac all over 2a. This should look familiar to you from lesson 5.6 on quadratic formula. Now we're set to reduce. Negative 10 times negative 10 is 100. And then 4 times 1 times 35 is negative 140. All over 2 times 1, which is 2. Continue reducing underneath the radical, which is what we call the radicand. 100 minus 40 is negative 40. All over 2. Then what popped up is a negative underneath the radical. So we have I square root of 40 over 2. And then we try to break down 40 into a product of 2 or maybe 3 numbers? Well, we can rewrite that as 20 times 2, or 8 times 5 is 40. Or I can rewrite that 8 as 4 times 2. So it'll be 4 times 2 times 5. 4 times 2 times 5 is 40. Now notice what pops out. The square root of 4 is 2. So we have negative 10 plus or minus 2i. Then what's left is this 2 and 5. 2 times 5 multiplies back together to give us 10. And then all over 2. Now we can do one more thing. We can separate this large fraction into 2 fractions. And then here's what cancels. Negative 10 divided by 2 is negative 5. And then this 2 and 2 cancels. So you have plus or minus I squareds of 10. Those 2's cancel out. I'm going to stop the recording there and then pick back up again with 5, 5.